Assalamu alaikum. So welcome to another video of integration. Yes, so in this video we will be starting off with a seemingly trickier model known as integration by parts. Model number 12, integration by parts. So just listen to the concepts carefully and write each and everything I tell you to write. Okay. So before starting, I would like to say that if you need private tuitions from me personally, the contact number is in the description below. All right, so you can go ahead and contact me. So yes, without any further ado, let's start. Model number 12, start writing. When two functions, when two functions are multiplied in such a manner that there exists no relationship, no relationship between the two terms then in order to integrate we will apply integration by parts. We will apply integration by parts using the Lie technique, such that the term appearing first such that the term appearing first in Liet will be V, and the term appearing appearing next in Liet will be U dash, and hence we will apply the formula. We will apply the formula VU minus integral of UV dash. All right, this is the formula that we will apply. Basically, when two functions are multiplied in such a manner that there exists no relationship between the two terms, then in order to integrate, we will apply integration by parts using the Liet technique, such that the term appearing first in Liet will be V and the term appearing next in Liet will be U dash, and hence we will apply the formula this. So first, let's recap what Liet is. This is something I told you when doing differentiation, right? Liet. L is for logarithms. I is for inverse. A is for algebraic. T is for trigonometry, metric functions. and E is exponential, right? So let's say when you encounter an integration question where there exists no relationship between the two terms being multiplied, remember when there does exist a relationship between the two terms, we often apply integration by substitution. But when two terms are being multiplied in such a manner that there exists no relationship, then we will apply Liet in this order, right? The term appearing first, let's say a logarithmic function appears first, right? So that will be V, and algebraic function appears next. That would be U dash, right? Let's to understand it through an example, right? And once we have identified the following V, U dash, and eventually V dash and U, then we can apply this formula, right? Then we can apply this formula. I know this doesn't make much sense at this stage. When we are going to start doing example questions, then you will understand what I'm talking about. All right. It's okay if it doesn't make sense right now. Let's try our first example question. All right. And I'm sure it would get clearer to you as we move on. So let's say we have here with us, we need to integrate x sine x, right? Now, just write Liet for your easiness. Now look at this. Which term appears first? Which term appears first? It's an algebraic function, right? This term is being multiplied to a trigonometric function. So the term appearing first is algebraic in this particular order. So what we learned that the term appearing first would be V, all right? And sine x is a trigonometric function, right? Trigonometric function comes after algebraic function in this Liet order, all right? So it would be U dash, all right? So let's write it over here. V is x and U dash is what? Sine x. Now we need to find V dash. It would be 1, and the integral of this would be sine x integral is negative cos x. Now we can apply the formula which we learned, which was vu minus integral of uv dash. Now this can be easily applied here. All right. So let's just apply it. So v x u negative x cos x minus integral of uv dash. We have u, all right, and we have v dash. There's no need to write it here again. All right. So basically, integration by parts involves double integration because now you will have to integrate this as well again. All right. So negative x cos x, if this goes outside, it turns positive cos x, and integral of cos x is sin x. All right. Negative s x cos x plus sin x, and don't forget to add plus c, which is the standard when integrating. All right. The only case in which you will not apply plus c is when you have a definite integral. All right. So this is how you do it. Now let's do a couple of more example questions to understand this. Now let's say we have x ln x. So our first step is to write a Liet here and check the order, right? So first term, this first, now logarithm is the second term, right? So we are going to check this particular order, all right? So the first term appearing in the Liet order would be always V, all right? And since the algebraic uh, function is afterwards in the Lie or after logarithms in the Lie order, so it would be u dash. All right, this is what we learned, v and u dash. The first, I'm going to say it again, the first function coming in this order, right? Whenever you see two integrals being multiplied, such as in this case, the first term in this particular order of Lie, in this case logarithms, will always be v. And the term coming afterwards, in this case algebraic function, would be u dash. I hope we are clear on that. All right. So now just simply write it here. So v is ln x and u dash is x. All right. So what would be v dash? V dash would be 1 upon x. And what would be the integral of u dash? It would be x squared upon 2. Now what we have to do is we have to just apply the formula. The formula is vu minus integral of u v dash. All right, so we have this v with us, which is ln x and u x square upon 2 vu minus integral of u v dash. So we have u and v dash is 1 upon x. So we can write this as x square upon 2 ln x. We can take 1 upon 2 outside. So it would be, you can just simply cut this, right? So it would be x upon 2. All right. So we can now just take this outside. X square upon 2 ln x minus 1 upon 2 integral of x. All right. So this would be x square upon 2 ln x minus 1 upon 2 x square upon 2, and never forget to add plus c. So finally it would be plus c. This is the answer. All right, so this is how you do it. Now a couple of more questions. So now let's say we have just ln x. All right, now how can you integrate ln x? We have learned that ln x could be differentiated, but here the question asks you to integrate ln x, and we haven't encountered a model of integration which integrates ln x alone. Now there is a trick here. There's a slight trick here, right? Notice that if there is nothing here, there is always 1 being multiplied. So this is basically 1 ln x. All right. Now you can apply Lie to it. You can apply Lie, and 1 is an algebraic function. 1 is an algebraic function, and ln x is logarithms. All right. And in this particular order, L comes first, so L would be V, and A come afterwards, so it would be U dash. All right. So here is the catch here, that the question gave us simply ln x, and we know that if there's nothing attached to ln x, there's always a coefficient 1. All right. So this was the trick here that you needed to identify, and this is something very common in exams. The examiner would always give you trick questions. All right. So let's just do this. So we have b with us, which is ln x, and the u dash with us, which is 1. Now v dash would be 1 upon x, and the integral of this would be x. All right. Now simply apply VU minus integral of u v dash, the formula. We know v is ln x and u is x, so it would be x ln x minus integral of u and v dash, which is 1 upon x into 1 upon x. So it basically gets cancelled out. So x ln x minus integral of 1, and integral of 1 is x plus c. So this is our answer. Hope this makes sense. All right, let's do some more examples. Now let's say we have with us x plus 1, the whole thing power 7. All right, so in this question also we have to apply Liet. All right, in this particular order. Now let's firstly identify. All right, so this is an algebraic function v. All right, in this particular order v, and this is, since this whole bracket has a power attached, this can be counted as an exponential function. So this would be u dash. All right, the first one in this order is always v, and the second term appearing is u dash. All right, so we have v with us, which is x, and u dash, which is x plus 1 upon x plus 1 to the power 7. So v dash would be 1, and u, the integral of this would be x plus 1 upon 8, 7 plus 1, 8, upon 8 into differential of the bracket, which would be 1. All right. So let's apply the formula, which is vu minus integral of u v dash. All right. So v is x and u is x plus 1 to the power 8 upon 8 minus integral of u v dash. So vu is x plus 1 to the power 8 upon 8, and v dash is 1. All right, we can leave it as this. All right, so now what we'll do is move 8 outside. All right, and now we have to integrate this like we would normally would. So this is our answer. All right, I hope this makes sense. Now let's jump on to a bit more complex question. Now let's say we have x square e x dx. So this is our integral. Now we have to identify. First step is to write Liet. All right. All right. Now we have, this is an algebraic function, so it would be v, and this is an exponential function, so it would be u dash. first term appearing in the Lie order is V, and the second term appearing in the Lie order is U dash. Right, so V is x square, U dash is e to the power x, so V dash would be 2x, and the integral of this would be ex. All right, so now you have to apply the formula, which is vu minus integral of uv dash. All right, so v is x square and vu is ex. All right, vu minus integral of u v dash 2x. We can write it like this: integral of 2x e to the power x. All right. Now notice that in order to integrate this, right? In order to integrate this, we again have to apply Lie. All right, because these are two functions being multiplied with each other, which has which have no common relationship with each other. So, all right, so you will leave it as it is for now. Leave this as it is for now and integrate this separately using Lie. All right, 2x e to the power x. So basically, Lie is being applied two times in integration by in a single question of integration by parts. All right, so now identify in the Lie order. You can see 2x is would be v, 2x would be, since it is an algebraic function, it would be v, and ex coming afterwards would be an exponential function, which is u dash. All right, so v is 2x and u dash is e to the power x. So v dash would be 2 and u will remain as it is, which is ex. Now apply vu minus integral of uv dash here. All right, so v u minus integral of u and v dash, which is 2. All right, 2x e to the power x minus integral of, we can move to outside, integral of e to the power x. All right, now we have to integrate this. So the integral of ex is ex. All right, 2x e to the power x minus 2ex. So what we did, we applied integration by parts again in integration by parts. All right, let's recap what we did. We encountered a question. All right, we identified that Lie is being applied and we used the formula and applied Lie. All right, now we noticed that in order to integrate this integral, we again have to apply Lie. So this is exactly what we did. In order to integrate, we applied Lie again. And after applying Lie, we got this. So the integral of this is this, which we got by applying Lie again. So now just simply write this in place of this. So x square ex minus 2x e to the power x minus 2ex. All right. So the final answer would be, and don't forget to add plus c. So this is the final answer. I hope this makes sense. Let's try another one. All right. Start by writing Liet. This whole thing is an algebraic function, so it would be V, right? And this is trigonometric. It would be U dash. Comes afterwards in this order. All right. So we have identified V, which is 3x square, and we have identified U dash, which is cos x. All right. So V dash would be 6x. All right. And the integral of cos x is sin x, right? Now just apply the formula, which is VU minus integral of UV dash. So we have with us V, which is 3x square, U, which is sin x minus integral of U, V dash, which is 6x. All right. So 3x square sin x minus integral of 6x sin x, 6x sin x. All right. So, right. So let's move 6 outside, and we are left with integral of x sin x. Now notice what's happening here. Again, we have to apply integration by parts. All right. So let's apply integration by parts again to this one. Let's write it over separately with a different color. So x sin x, we have to apply integration by parts here again. All right. So in the Lie order, algebraic function comes first, which is v, and sin x comes afterwards, which is t. Or let's say it would be u dash. So v is x, and v dash would be 1, and u dash is sin x, and the integral of sin x is negative cos x, right? Negative cos x. So just apply the formula vu minus integral of uv dash. So we have with us v, which is x, and u, vu minus integral of uv dash. We have with us u, and we have v dash, which is 1. So negative s cos x right? Now just write it in place of the integral. Let me use a different pen. 3x square sin x minus 6 negative x cos x plus sin x. So 3x square sin x minus minus plus 6x plus 6x cos x minus 6 sin x plus c. This is our answer. All right. So nothing new happened here. This is exactly the same approach in the previous question we did. But again, let's recap it. So we encountered a question, and we identified that since there exists no relationship between the two multiplying terms, we have to apply Lie. All right. We identified v and u dash, and we applied the formula, and this is what we got. This is what we ended up. And then we identified that in order to integrate this, Liet needs to be applied once again because there exists no common relationship between them. All right. So what we did, we applied Liet again. And this is what we got. eventually. All right. And this, and we substituted this in place of this and just simplified it. All right. So there, in exams, there are going to be questions which involve you applying D8 two times. All right. So this is something you need to practice. Now moving forward, I hope you are clear so far. Now there is a very special and a very unique case which is within integration by parts itself, and that is the case of a never-ending integral. Wait a minute. Yes. So the special case of never-ending integrals. This is something which I will make you understand through a question in exactly 2 minutes from now. But before that, just write a short note. Whenever you are encountered with a never-ending integral, which I will obviously explain in 2 minutes from now, never-ending integral, please observe, please observe that after two cycles, the question will start repeating itself. The question will start repeating itself. All right. After two cycles, the question repeats itself. Now let's do it through an example and figure out how to solve it. All right. So we have this ex sin x. Now it looks like a totally normal integration by parts question, but the twist will come on in just a few minutes into solving this question. All right. So let's start. Just like how you would solve a normal integration by parts question, start off by writing Liet and identify what comes first. Since trigonometric function comes first, it would be v, and exponential come afterwards, so it would be u dash. All right. So we have with us v, which is sin x, and u dash, which is ex. So v dash would be cos x, and the integral of ex is ex. All right. Now just apply the formula. So vu minus integral of u v dash cos x, right? Sin x. So we have sin x ex, or more simply ex sin x minus integral of ex cos x. Now notice that again we have to apply integration by parts here. So this is exactly what we are going to do. All right. Apply integration by parts again. So I hope by uh, I hope by now I don't have to write d8 again and again. I'm sure you can, with enough practice, you can do it in your head. So ex is u dash and cos x is b. All right. So b is cos x and u dash is equal to ex. So v dash would be negative sin x and u would be ex. So we will once again apply vu minus integral of uv dash. Now v is cos x, u is ex cos x minus integral of uv dash. So u v dash ex into negative sin x, ex cos x minus minus plus integral of ex sin x. Now notice that the question is repeating itself. So this is exactly what the question was. It was ex sin x. And now if we try to solve this, if we try to integrate this again using integration by parts, we will result in a never ending integral, and this will go on forever and ever and ever, because this whole thing would keep on happening. We will again start from here, and then we will again end up here, and again start from here, and again end up here, and so on and so forth. So this will keep on happening till forever. All right. So here's how you do it. I made you write a note. Whenever you are encountered with a never-ending integral, please observe that after 2 cycles, the question will start repeating itself. So this is exactly what's happening. After 2 cycles, first, second, the question is repeating itself. All right. So here's how you handle it. Just write this as you would normally would in place of this, because we have integrated this, right? Just write it like it. Ex sin x minus ex cos x plus integral of ex sin x. All right. Simplify it. Ex sin x minus ex cos x minus integral of ex sin x. So this is definitely not the end, because we need to integrate this. Now what you're going to do is that you will make this the subject. All right. Just do just simply copy what I'm doing here. All right. Make this the subject here. All right. Make this the subject. Just write integral of ex sin x would be this. All right. Now you are going to move this towards the left, and when this goes there, it would be 2 integral of ex sin x is equal to ex sin x minus ex cos x. All right. So the integral of ex sin x would be e power x sin x minus ex cos x upon 2. All right. This, and plus c, of course. This would be the answer. All right. I know it doesn't make much of sense as of now, but as you would do practice and practice and practice, of course, it will make sense. Now let's recap it once again what we did. The special case of never-ending integrals. What are never-ending integrals? Integrals which start repeating itself after 2 cycles. And what are those 2 cycles? First cycle, ex cos x. And when we integrated this, right, another integral appears, which is exactly the same as the question. And if we integrate this again, we are going to be stuck in an infinite loop. All right. So in order to tackle these types of questions, what we are going to do is that we are going to insert this back here. All right. And we are going to introduce this on the left side like this. All right. And we're going to move this as well to the left side and make it the subject. All right. And this is, and we'll just simplify it. And this is eventually what we would get. All right. I hope this makes sense now. And with that being said, we are now done with integration by parts. All right. And now we have only three models left. One is a new one, and the remaining two are something you are already familiar with because they are from AS. All right. And with that being said, we are about to near the end of this integration series. All right. So one thing more, if you need personal tuitions from me, the my contact is in the description below. Reach out to me through that number, and I will see you in class. All right. So that's it. That's it for today. See you in the next video. Thank you. Take care. Allah.